Hi, welcome to our new Parametric Statistics project. We're going to present the results of our project titled Vacuum Leak. In this project, we're going to statistically analyze a database called Vacuum Leaks, which we got from Nissan Mexicana. This database is used to obtain the trends of say vacuum leaks process. The discussion is potentially intended for powertrain machining supervisors and general supervisors. They use the results to project the state of the production line, which in this case is for the MR engine cylinder production line. The process consists of verifying that the intake and exhaust chambers, in total 7, comply with the Nissan standard, which is 300 to 450 psi. It should be noted that it says the limit, the superior limit, it doesn't have an effect of the engine performance. On the contrary, it's beneficial. But it drops below the 300, the engine will not work well and there will be complaints from the engine assembly plant. Each chamber has two bolts within much place to press them to later be placed in the vacuum leak machine and obtain the result. It must be pressed for 8 seconds and the machine indicates the pressure. What is done in the process in the machine and intel of the exhaust and intake bulbs, this machining machine has a tool for exhaust and another in the intake. So the same tool manufactures 8 belts and either exhaust or intake. What we're trying to know is that if the tool change at the end of the month is the reason why low pressure are obtained at the end of the month. Next is the time to start with the methodology of the project. Methodology. As we mentioned earlier, what we want to demonstrate is that if the tool change at the end of the month, cause the pressure in each take and exhaust chamber to be improved. So H0 is the tool change at the end of the month made a change to the pressure level of the intake and exhaust chambers, and HA is the tool change at the end of the month did not make a change to pressure level of the intake and exhaust chambers.
Okay, so first we perform the anomaly test to verify the data belong directly to the normal distribution. The Shapiro-Wilk test will have a null hypothesis that it meets the normally assumption, and the alternative hypothesis is it does not meet the assumption. As we saw in the test, most of the samples from October chambers do not fulfill the normally assumption. And in the data from November, we see that the most of the chambers measured do fulfill the normal assumption. With the results, it was decided to use a non-parametric method and to compare the medians of the samples between the intake, the admission, and the exhaust chambers. Okay, so we use here to compare the medians the Kruskal-Wallis test. With a null hypothesis, the medians of the sample are equal. An alternative hypothesis is the medians of the samples are different. We use an alpha of 5%. So using the Kruskal-Wallis, we observe that in each set of samples, the medians meet the null hypothesis. The medians of both admissions and exhausts are equal. To finalize the test, we compare the medians of the complete data sets between the months of October and November to measure the effectiveness of the tools in this case using again the Kruskal-Wallis test. So we observe that the null hypothesis is fulfilled. The medians of the pressures are the same in the both months. So we can say that the tool have the same effectiveness in the month of October and November.
Conclusion: as observed in the Kruskal-Wallis test, the medians of the chambers are the same compared to those of the following month. That is, if we compare the chamber number 1 of October with the chamber number 1 of November, we see that they effectively have the same median. This shows that tool calibration is the same for individual chambers. Also, if we compare the medians of the chambers measured with the tool of October versus November, we observe in the same way that the medians are the same. We can analyze with this test that the calibration of the tool for each month is the same, that there are no significant differences observed in the calibration and measurement of the tool. Therefore, changing tools every month to measure the chamber's pressures doesn't imply a significant change in the chamber pressure measurements. From what we can visualize in Nissan, the tool change every month is necessary to check the measurements. This wear of the tool is significant So making a change of the tool every month has to be considered. In the same way as it is important to consider that the pressure measured with the tools, although they are different, they should be the same. An alarm must be generated when the medians are different. In this case, we do not compare the medians because most of the chambers are not distributed in a normal way. In further studies, it will be helpful to analyze which is the perfect moment to change the tool. Instead of a whole month, maybe it can be like every 3 weeks or 3 weeks and 2 days or something like that to be sure it's the perfect moment so it doesn't make wrong measurements, but it still works fine. As a general conclusion, along the whole class of non-parametric statistics, we have studied a lot of different statistical processes, which gave us different approaches to analyze information as it is the case of non-parametric data. We have learned how to use the Gaussian kernel, which helps us to approach a statistical distribution to data who doesn't have an exact distribution. Also, the bootstrap method helps us to analyze how precise are the estimators of the samples. Also, the Kaplan-Meier help us to identify the survival function of data with right censorship. The Kendall, Pearson, and Spearman correlations help us identify if there is linear correlation between two variables. Similarly, logistic regression helps us make predictions of a certain model. All this knowledge is and will be really helpful in our professional life as statistical industrial engineers. We have nothing to say but than to give thanks to our professor for teaching us everything and helping us out in every way he could. Thanks a lot.